Swayam Prabha. Digital India. Educated India.
Hello everyone, welcome to our NPTEL online certification courses on engineering drawing and computer graphics. I am Rajaram Lakraju from IIT Kharagpur. We are covering module number 2 on conic sections. We are at lecture number 9. In module 2 conic sections, we have already covered some of the principles on geometric constructions. For example, how to bisect a line, how to bisect an arc, how to draw perpendicular lines, how to divide a line, how to bisect an angle, how to trisect, how to divide circles and circle through 3 points. In today's lecture 9, we are going to cover how to draw normal and tangent to a circle. The second part of the thing, how to draw tangent to a circle from an exterior point. Finally, we will cover how to construct a regular polygon of a given side. The first question what we will ask is, if there is a circle, how to draw normal and tangent to that circle from a given point. In certain instances, we might be having only 3 points. So, using 3 points, first of all we have to construct a circle, then we will be in a position to identify the center and then radius. Once radius is done, we will pick the point, normal direction vector we will write and also tangent direction we will be in a position to do. Let us do that step by step. Let us consider here 3 points are given A, P, B. First of all, we have to identify a circle passing through A, P, B points and then center of the circle. Let us do it on page. The first point, so let us identify 3 points A, perhaps P and point B. Let us name them A, P, B. These 3 points are given. What we have to do is, first of all, construct a circle through this. A, P and P, B. Now, let us construct perpendicular bisectors for P beginning with center A and also center P. Similarly, construct the next perpendicular bisector from P B. So, identify these intersection points. These are perpendicular bisector lines for P B. So, intersection point is O, through which we have to construct a circle. So, this is the circle what we get. a circle passing through A, P, B points. Now, we would like to construct a perpendicular bisector for O, P and R kind of point, and this one what we are calling as normal. This is the normal direction to that circle passing through point P. Tangent always be perpendicular to this normal. So, for that purpose what we are going to do is pick any length from, perhaps this is the point Q what we are going to identify, and again another point we are going to identify. From these 2 points, let us call these points Q, this is R, let us call R, and this point as Q. So, R, P, Q, whatever the perpendicular bisector, that we will call as tangent to that circle. Again we have to construct similar way with radius more than half of it. Center R with the same radius, join these points, which will pass through P. So, now let us identify the tangent line and the normal line. There are various ways of constructing tangent and normal in these directions. If you have a set squares or mini drafter, you can always align normal to that, passing through that P point gives you a tangent, and this is normal to that circle. This is the way we construct it. Let us look at the procedure. First of all, we have to construct a circle passing through A, P, B points. Once it is done, we have to construct a line from O to P and then extend that OP line all the way to R. That line OPR, whatever the line extended O to R, we call normal to that circle. And to construct a tangent to the circle passing through P, what we do is identify the P point, around that an equal distance R and Q points first we will identify. Using Q and R as centers, construct one more perpendicular bisector passing through P, so that S point we will be in a position to identify. Let us call this is S. So, S P M gives me tangent, Q P R gives me normal passing through point P. Any other point on the circle also it works in the similar way. Let us look at the second problem. How to draw a tangent to a circle from an exterior point P. So, here what is given is there is a circle having a center O, passing through points J and K with specified radius, and there is an external point P. From point P, one has to draw a tangent passing either through J or through K. To do that, let us look at the procedure. First of all, what we have to do is join center of circle O and exterior point P. So, that circle is given and we are going to extend it from O to P. Draw a perpendicular bisector to OP. So, OP length line we know, use equal distances O as center, P as center, draw a perpendicular bisector, and this perpendicular bisector cuts OP line at point M. Once M point is identified, use M point as center and radius O to M, pick that length, M as center, cut the circle at point J. Now, we have that J point on the circle, connect P point and J point to construct a tangent line. Similarly, one can construct PK also as another tangent. Let us begin with one example. Let us pick radius of the circle as 30 mm. The point P through which we will construct tangent is something about 90 mm away from circle center O. So, first let us take scale, pick a point, let us call that point as O. P point is 90 mm away from center O. So, 90 mm let us identify on scale somewhere here. Let us call point P, and circle radius is 30 mm. So, 30 mm this is 30 mm. So, draw a circle. Now, we do not know where exactly this J point will be there. To construct the J point, what we are going to do is join O and P points. Joined by a construction line. OP is identified. Now, what we have to do is for point OP, we have to make a perpendicular bisector. For that, we pick P as center more than the half of the distance between O and P, make arcs on both the sides, identify these points, then join them. Now, OP line intersected at point M here, this is the one. Once we identify M point, what we have to do is use M as center and radius MO to locate J point. So, for that we pick M point, pick O, M as radius, identify the point on both the sides. let us call this point J, this point K. Now, join point J and P. So, this is the tangent to that circle passing through point J and P. Similarly, join K and P. Connect this by a line. So, tangent 1 and this is tangent 2. This is the way we construct tangents to circles. Let us construct a regular polygon. For example, we would like to make octagonal polygon constructed from AC given side. So, AC side is given for us and the same AC length we would like to have it on other sides. To construct that, let us look at the procedure. So, what is given is AC length is given as side length. First of all, we have to construct a semicircle passing through A with radius AC and center as C. So, let us pick an example. AC side length for the polygon what we are going to construct. The polygon what we are going to construct is octagon. So, it is supposed to have 8 sides. AC side length is a 20 mm side we would like to construct. Further, the first point is draw a 20 mm side. So, we are going to construct from the baseline AC. So, our octagon goes all the way in the upper. So, first identify point A, point A here and a side length of 20 mm. And name it C. Once that is done, C as center and AC as radius, we have to draw a semicircle. So, it is going to make a point B. Let us extend this one by construction lines. Usually we go with very thin dashed lines. So, semicircle is constructed. Now, we have to locate the remaining points like 1, 2, 3 and so on 7 points on this semicircle, because we would like to construct an octagon of 8 equal sides. So, we are going to divide this semicircle into 8 equal parts. One, we can use our protractor, divide this 180 degrees into 8 parts. So, the resulting angle we can really locate it. Otherwise, we have seen how to divide this angle 180 degrees by bisecting it, trisecting it and so on, that is also we can go ahead. So, as of now we will go ahead first divide this into different parts. So, first part 90 degrees, that means 4 zone we will be in a position to construct it. So, locate that fourth point. We have to divide that into 3 equal parts. So, the first part something like to construct 1, 2, 3 and 4 parts we are going to construct. So, to construct these 1, 2, 3 parts, what we are going to do is again we will divide this 90 into 4 parts. This is the 90. So, 45 degrees. To locate point 2. Similarly, divide this angle. We have seen if we instead of approximating into half angles, if we are not very careful about that, we know how to divide this into 2 parts. So, pick a radius, half of that, make an arc, similarly construct which is going to intersect here only and join these points. So, we will be in a position to identify point 3 also. Sometimes our protractor can't have least count like 22.5, 20 and so on things. So, it is always easy for us to bisect that angle. So, for 2 also we use similar protocol, make an arc, divide it. Anyway, it will pass through the center. Extend that lines, so that we have point 1 also. Similarly, if we would like to construct the other side 45 degrees, join them, make it the part 6 and divide this into 2 equal parts. Similarly, make equal parts. Extend these lines. To locate points 5, 6, 7 and point B. Once we divide this into equal parts, connect C and 6th point. This is the point what we have to connect. Draw perpendicular bisectors to AC. So, for AC we have to locate perpendicular bisector and also C6 perpendicular bisector. So, that outside kind of circle we will be in a position to connect, and from there it is quite easy for us to calculate octagon. To construct perpendicular bisectors for AC, what we are going to do, intersect on both sides, join these points to locate center of that circle. Similarly, C6 use this. So, this is the point through which we have to construct perpendicular bisector, use B and C, join them. So, one of the perpendicular bisector is this one, other one is this. So, both of them are intersecting here. So, locate this one as center. Name that center as O. Now, when we are going to construct an octagon, is always be circumscribing A, C and 6 point. This is the outer circumscribing circle. So, if I am going to extend points from C all the way there, where it is going to intersect, that point we will be calling H, join A and H. Similarly, from C point extend a line where it is going to intersect, call that one as G, join H and G. From C O extension is going to intersect there, join that, call point F. Now, from C extend a line, it goes, call this one as E, join F and E. Similarly, from C is going to intersect at D point, join D and E, join 6 and D. This is the way we construct an octagon. So, in lecture 9 especially we covered how to draw a normal and tangent to a circle, how to draw a tangent to a circle from exterior point, and how to construct a regular polygon, for example, like octagon of given side inscribed in a circle. In lecture 10 we will practice more examples. Thank you.